So today we're going to be going over some exponential word problems. I had already kind of covered this in the last video that I made over the notes, but today we're just going to focus on exponential word problems. I am going to do 3 practice problems with you, and then I'm going to give you 3 problems for you to work on your own. So this is our first example. Before we start, just a reminder of what a exponential function looks like. It's always y equals ab to the power of x, where a is your initial value. We also call it the start. And then we have b, our multiplier. Okay, and our multiplier can be greater than 1 or in between 0 and 1, which is like a decimal like 0.5, 0.2, 0.33, and so on. So let's go ahead and get into our first problem. Now, 3 things that we're looking for in this word problem as we're reading it or as we're looking at it. The first thing being our initial value, the starting value. We're always looking out for that. The second thing we look for is our multiplier, whether it's going to be greater than 1 or in between 0 and 1. And then the third thing is, to help us with the multiplier, is our problem telling us that the multiplier should be making the initial increase or decrease? So is our multiplier going to be greater than 1 or in between 0 and 1? Is it going to be increasing or decreasing as a multiplier? Is it going to multiply this and make it smaller, or is it going to multiply the initial value and make it even bigger? So that's what we're going to figure out as we're reading the word problem. Okay, so the first one says, a Gila monster is about 16 centimeters long at birth. During the beginning of its life, the Gila monster's length increases by about 15% each week. So first, we are going to find out the initial. Our initial value, according to this word problem, is 16 centimeters long at birth. Okay. So at the beginning, the Gila monster is 16 centimeters long at birth. All right, so that's our initial value. And then our multiplier, okay, is going to be, according to this problem, increasing. So our multiplier should be greater than 1 because it says right here, the length increases by about 15% each week. So it's going to increase by 15% each week. So again, we always start off with 100% whenever we're talking about our multiplier. Okay, and then either we subtract or add from this 100%, depending on our problem. Here it's telling us increase, so I know I'm going to add. Right, so what are we going to add? It's increasing by 15% each week, so I'm going to add 15% to my 100%. Okay, so let's go ahead and start writing our equation. It's going to be, and the word problem is going to go away, it's going to be y equals, okay, and then a, our initial value, is 16, and then I open parentheses. Our multiplier is going to be, again, 100% plus 15%, and it's plus because it is increasing according to our word problem. So it's 100% plus 15%. And then, of course, after you close this parentheses, don't forget your exponent is the variable x. Okay. All right, so let's simplify this. It's going to be y equals 16. 100% plus 15% is going to be 115% to the power of x. Okay. And then finally, one last thing is we do not want percent in our final exponential function, so we want to get rid of this percent. And the way we do that is we add our decimal here and we move it twice to the left. 1, 2. Okay. So 115% becomes 1.15 as an actual number. So our final answer is going to be y equals 16 times 1.15 to the power of x. Right? So I'm going to go ahead and pull this up. As you can see our equation with the word problem. Right? And we can make sure that we did this correctly. So again, our initial value should be what we start with, which our initial value here is 16 centimeters long at birth. And then our multiplier should reflect either growth or decay. And since this is 1.15, that means that this is greater than 1. Our multiplier is greater than 1, so that means that it should be growth. And that is true because it says here the Gila monster's length increases by about 15% each week. So this 1.15 represents 100% plus the 15% that it's increasing each week. So that's why it's 1.15. And then of course you have the power, which is always going to be x in an exponential function. So this is your final answer, and that's where we would stop.